Okay, so everyone, I want us to discuss three things, like I said. How to solve the equation by graph. That's easy. Especially the SL, you want to really take note of this. But I would not really expect this in an HL paper. Okay? So, but it's a good knowledge that we've even had from our IGCSE. So basically, this is solving cos x equal to 0.4. And this is in radian. That's why you have 0, 1, 2, 3, and so on. Your pi is 3 point something. So because it's cosine, your 3 point something is here. Am I making sense? Yeah. So don't worry about that. What is x if cos x is equal to 0.4? Do you remember how to solve equation by graph in IGCSE? You were looking for where these two graphs meet. Do you remember that?
Yes.
That's the idea here. That's the idea. So what I'm trying to say is this. I think we did something on simultaneous equation. Is it this class? One linear, one quadratic? Did you do anything like that here? Hello, talk to me. In Form 5?
Yes.
Like we are interpreting the intersection of the two graphs as a solution of simultaneous equation. That's the same knowledge. If I say solve y equals to f of x and y equals to g of x simultaneously. For example, y equals to x plus 1 and y is equal to x squared minus 3x plus 2 simultaneously. You equate them together, right?
Yes.
So you do what? X squared minus 3x plus 2 equals to? Then you solve. You're going to end up getting x is equal to x1, x is equal to x2, two values of x, right? Then you substitute these two values of x here to get two values of y. And when you get the two values of y, so y is equal to y1, y is equal to y2, yes? When you get the two values, you say, oh, one solution is x1, y1, and the other solution is x2, y2, yes?
Yes.
In geometric interpretation, what does this x1 and y1, x2, y2 mean?
The intersection.
The intersection. And that is obvious because this, will it be this or this? Concave up or concave down? This one. Concave up. This, will it be this one or this one? The first or the second?
First.
The first. These 2 points is actually here and here. Understand?
Yes.
This is algebraic analysis. This is what it means geometrically. Are you with me?
Yeah.
Now, there's a reason I'm talking about this. In IGCSE, which is something we are teaching if anybody has a younger brother in Form 3 and Form 4, these are some of the things we did with them this term. This geometric significance of their results. If we are asked to solve the quadratic, maybe they were given a graph. They were given the graph of y is equal to x squared minus 4x plus 4. Okay, let's say minus 4x minus 5. It must have crossed the x-axis at minus, if you factorize this, that would be x minus 5, x plus 1, yes?
So negative 1
So
and
it
5.
should be negative 1 and 5. That's where it crosses, yeah? So we will normally give them, this is IGCSE. We will give them this quadratic, and the question will be, use this graph to solve, maybe question A, x squared minus 4x minus 5 is equal to 0. Question B, x squared minus 4x minus 5 maybe is equal to 1. This is your curve on the left.
Yeah.
This is another line on the right. This step is exactly what you did here. What do I mean by that? It means equating these two, the previous step, what somebody thought of, was trying to solve two equations. One of them, y equals x squared minus 4x minus 5. The other one, y is equal to 0. That's what somebody was trying to solve. That's what you did here. When trying to solve this and this, you equate both of them together. So if someone gives you this, it means, oh, these are two separate equations of graph. Understand? So basically, and from what we just said, oh, the solution of this means the point of intersection of the curve on the left and the line on the right. Am I making sense? It could be the point of intersection of two curves too. This is IB. Of course, IBCSE will limit to this. But IB could give you this and this. It's possible. I'm not saying IB will give you, but you are not too young to do that. That's what I'm saying graphically. Even more complex ones. My point is, this simply means find out where this intersects with y is equal to 0. Ladies and gentlemen, we know this left. Y is equal to this curve. Y is equal to this equation is this curve, right? What is y is equal to 0? What does it mean?
The line.
Which line? It has a name.
Oh, the
X-axis. That is why we say that the solution of this equation graphically is the x-intercepts. But this is actually what is happening. Understand? Because we are trying to find out where y is equal to this intersects with y is equal to this. We are trying to solve the equation simultaneously, but in graphical form. By graphical method, I mean. Understand that? So I want you to really understand what is happening geometrically before we can talk about this. So when someone asks you to solve this equation, okay? When you're asked to solve this equation, you're looking for the point of intersection of two graphs. Anika, tell me one of them. If you're trying to solve this equation, the solution of this equation means the point of intersection of two graphs. Which one is one of them? What is one of them? Just like this. This means the solution of two equations, where two graphs meet. Right? One of them is y is equal to x squared minus 4x minus 5. The other is y is equal to 0. That's what we just said here. Understand? What about this one? It's the intersection of two different graphs. Which one is one of them? I didn't say the one on the top when I answered this. I told you the equation. Can you tell me what the equation is? Unless you've not been following what I've been saying. Have you been following what I've been saying? Do you understand what I said here? So I don't know why. Yes, Jesse, you want to try? Speak louder, please.
Was x equals 0?
No, that's not what I asked you. Give me one of them. I'm not asking you to read what is on the board. Don't read because x is equal to 0.4. That's not what I want to hear. What is one of the graphs whose intersection gives us the equation? That's my question. One of the graph is what? Carolina, your turn.
Y equals to 5x.
I just gave you a sample here. One of them is y equals x squared minus 4x minus 5. The other one is y is equal to 0. I'm asking you to repeat the same thing. Why is that a problem? Come on. Ada, what's the second one? Jesse, you want to try again? Second one. Say that again.
Y equals 0.4.
Better, not 0.4. Maybe I say this again. This solution of this equation is the point of intersection of this graph and this graph. This graph y is equal to this is here. This is here. So finding the solution of this means finding the solution of this. Finding the solution of this means finding the solution of this. The left-hand side gives you the first graph. The right-hand side gives you the second graph. That's all I'm saying. I've said it here also. And that is why we say, okay, where this meets with y is equal to 0. Y is equal to 0 is the x-axis. That's why we say where this curve meets with the x-axis. That is why this would be the answer. So here we just be x is equal to -1, x is equal to 5. That's it. And for the second part, it's going to be the point of intersection of two different graphs. Anika, give me one of them. Speak louder and fast. We have no time. That's not the first one. I don't know why you're going to another one. That's not the first thing I see on the board, unless you're trying to avoid a difficult one. Ada. Have I been communicating? Because I don't expect this to take this long. Have you been listening to what I've been saying? Do you understand what I've been saying? Kind of. Denise.
X is equal
X equal to?
wait.
The first graph is which? What is the first graph?
X.
Ryan, wanna try? I'm trying to rush this thing so that I have time to do some stuff. You guys are not helping matters at all. I've given you something so simple that even Form 1 should be able to tell me the answer within 3 seconds. I don't know why this is such a big deal. Who wants to try, please? I don't have time. Yes, sir.
Y equals to x squared minus 4x minus 5.
And the second one will be?
Y equals to 1.
It's still here, circled. The point of intersection of the left and the point of intersection with the right. The left is y is equal to this. The right is y is equal to this. These y's were removed when you equate them. Just put it back. How is this difficult? Come on. You need to know this thing can be very frustrating, especially when I have stuff to do. And I need to be sure that you can get this before I move on. It means I have to delay the whole class. It's written there on the board. Just put y is equal to, call what you see on the left. Y is equal to, call what you see on the right. How is that difficult? Really? Come on, help yourself. Don't just lay back like, oh, I can't do it, so I'm just going to shut off my head. I can't think. Come on. I don't think this is a difficult stuff. These questions are that simple. Because if you do not understand what we are doing, forget about what you are about to do. But you need to understand what we are trying to do here. Otherwise, the whole worksheet in front of you will just be, oh, how do I do this? When you get to the next question, you need to ask, how do you do it again? If you don't understand the logic behind what we are doing, and that's what I'm trying to ask. This is frustrating, I have to tell you the truth. So, here, class, together, because I don't think I have time to do this again. The solution of this equation, can somebody explain to me? It will be the point of intersection of which graph and which graph. Explain. Anyone? No time to waste to call people now. Yes, quickly.
It is the point of intersection between y equals to cos x and y equals to 0.4.
That's exactly what we've been talking about here. IGCSE, even from 2, this is from 5, come on. So, this is always going to be given or expected to be found by with your calculator. So, the graph is plotted already. All we have to do is plot the graph of y is equal to 0.4. This is 1, this is 0.5, so this is 0.4. Just draw the line y is equal to 0.4. And wherever they meet is the solution. And you were given the interval. You must work with the interval. If this graph gets to 10 and the interval given is 0 to 4, you cannot state your answer beyond 0 to 4. And so when the line is drawn, you could see the line y is equal to 0.4 has been drawn. Even the answer is on the board. You just look at where they meet. So this is just your ruler and your pencil. You trace it down, and you write out what that is in one decimal place. And that's all. That's all. Okay? Sometimes the question might be given in terms of pi. I don't know if there's an example on that. There's no example. So sometimes it will say, solve this equation between 0 and 2 pi. Just check in your calculator. Pi is 3.14 or 3.1. One decimal place. 2 pi will be what? 6.2. It means your answer should be read up to here. That's all. Okay? So everybody look at question 1 quickly. Question 1 says, solve that equation for blah, blah, blah. What is the second? Yes, sir. All right. The second line to be drawn will be y is equal to what?
0.3.
Because what has been given? Sin x was not given.
Y equals sin.
Y equals sin x was given. So draw that quickly. Please, no time to waste. Draw. Stop talking. I don't have all day. Thank you. It doesn't have to be a broken line, but it could. But because it's a line, I don't think you should do a broken line. Draw a straight line. Yes? What? What are you doing? What that question needs you to draw. Unless I have to tell you what to draw again. Do what I did here on the board. Do similarly for question 1. So there are 4 questions, right? Right?
Yes.
So just do A and B. No. A and C. 1 number, 1 pi. Just to save time. Okay? A and C. So later, you will have to do 4 of them. The other 4. Is that a pen or pencil? Okay, great. What are you doing, Alex? Where's your line? Okay, great. So when you do the line, you can trace it down like that. It's on the board. Okay? Look at the board if you need to. You see how it was traced down? So it doesn't have to be an arrow. This should be a thick line. This is what I would tell you. It should be a thick line, but when you're tracing it down, you have done graph in IGCSE days, right? Then you drew a broken line to trace it down to the x-axis. Then you read it out. Just A and C. Question 2 also, go to A and C. 1 A and C, then 2 A and C, please. What's the problem?
I did wrong. I didn't see that 0.5 instead of 1 or so.
Okay. Have you done it? There are 4 of them. How many solutions do you have? 4. All right. You could write 2, 2 because of the space. The space is the time. There are 5? Oh, okay. But you could write everything on the line as well. All right. But not, you don't have to erase it. So go to this one next. Then go to number 2 also, A and C. You could write it like that too. The solution of cos blah 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 in radian r if you want. Or you could just write x is equal to, it's fine. So we must see your line clearly. That line y is equal to whatever must be clearly seen. Okay? We want to see that line. It must be drawn with a ruler and pencil. No freehand sketch of the line. you done? Please, can you minimize your chat? I have a lot of things to do. So that's that about graph. So we could also check the second on the next page while I try to explain the technology once to everybody. Like I said, both ideas can be done within 30 minutes. The rest of more practice will be done on your own later. So you just stand, then cos of double angle. So it's the same way. Okay, what I've done in number 1 and 2 that you do for number 3 and the rest. You need to say x is equal to, not just 2.9, 2.4. X is equal to, for each of them. Okay? Mister, take one and send to the ladies. I did one here for Ryan. Thank you, sir. We're going to keep one for Ryan. Right, Ryan on next. We'll do this. So this is what I've said, and this is what we have done. Okay? So we now want to use the graphic display calculator. Yanko is a Texas Instrument, right?
Yes. Yeah, the first one.
Oh. This one?
Yes.
Okay, everyone, please pay attention. We want to use calculator, so let me play this for you. Elson, could you help with that lighting again? Okay, for this one, maybe I
Since
can
trigonometric functions.
although we have explained, but Elson, quickly please. Although we've done this, but let's just hear, there might be additional information from the author, okay, apart from what I've said. So please listen, and I'll play the second one, and we can quickly do what we need to do.
Since trigonometric functions are periodic, trigonometric equations usually have infinitely many solutions unless a restricted domain is given. In this question, we are given the graph of the cosine function cos x from 0 to 10 radians. On this restricted domain, the solutions to cos x equals 0.4 occur when the graph intersects the horizontal line y equals 0.4. We can see this occurs when x is approximately 1.2, 5.1, and 7.4 radians. These are the solutions of the equation on the restricted domain.
Does that make sense? So for the graphical, using the calculator, it's similar to the first one. The only difference is you have to plot the graph yourself. There are two ways to this before I play that. This is the equation given. You plot the graph of the left on your calculator as your y1. We've plotted graph in the calculator before, right?
Yes.
Then you plot the graph of this and go for intersect, G-sub. Understand?
Yep.
Or, who can tell me another way to do that? Yes.
You put 4 minus x to the left side.
You bring this to the left, then you have equal to 0. And when you plot the graph, what do you look out for?
X.
The root.
X-intercept or roots. Understand? Roots. I don't think it's called x-intercept. I think it's called roots in our calculator, but you can check. I'm not sure. So root means x-intercept. For root, it is by default equal to 0 format, just like this equation in question A. But if you are plotting them separately, it means there will be a curve and a line. Now, IB has a rule. On every IB paper, there's always a rule that if you are solving by graph using your calculator, the only proof expected is that you sketch what you can see in your calculator, so that they know that is how you got it. Understand? Let me try to see if I can find that. Oh, I don't think I will have access to that drive. Okay, but I don't have it here. Okay, I need Okay, let me see if someone has one. Math, come on. Okay, all papers. Maybe someone has something. Math, HL, or SL, it doesn't matter. Remember 2020. Okay. Now, watch this. Can I remove this? Okay. Full marks should not be awarded, answer must be blah blah blah. Oh, there is something about graph. I think previous section 2. No, it's not here. Anyway, maybe I'll try to find one of the latest papers, but this is, yeah, let's check HL2. Ah, look at this. Can you see?
Yeah.
Can we read that? For example, if graphs are used to find a solution, you should what? Sketch this as part of the answer. So as we are using calculator to solve this, that's the reason for the worksheet I've just given you. I put a space. You sketch it. Of course, your calculator sketch it for you, right? You just draw what you see in your calculator, basically. So it's not something that requires some special skill.
Okay.
Understand? So let's go back to our normal life. Listen to this.
In this example, we use technology to solve a trigonometric equation numerically. Notice there is a restricted domain, which ensures there is a finite number of solutions. To solve the equation, we start by graphing the expressions on each side of the equation on the same set of axes. On a calculator, we set y1 equals 2 sine x minus cos x, and y2 equals
Just
4
wait.
minus
We'll use
x.
calculator. Just listen.
We need to make sure the mode is set to radians. We then graph the functions and make sure the window settings are just larger than the domain. For more instructions, you can click on the icon. Locating the points of intersection on the given domain, we find that the x-coordinates are approximately 1.82, 3.28, and 5.81. These are the approximate solutions to the equation.
So all I